Hi folks, we're taking a look at number 14 from page 179. Okay, it's a good question to test your basic algebra skills. So what we've got is this curve here, and we're considering any tangent to this curve. Okay, and they want us to show that the sum of the intercepts, meaning the sum of the x and y intercepts of this tangent line, will always be equal to k. Okay, so since we're looking to find information about the tangent line, first thing to do is to find an expression for the derivative so we can find an equation of that tangent line. Okay, so let's find the derivative of this here. Since y is given explicitly, we're going to use implicit differentiation. So differentiate both sides, derivative of root x with respect to x. We've done this many times, so we know that that's 1 over 2 root x. Okay. And then here, first we have to take the derivative of y with respect to y. So 1 over 2 root y times the derivative of y with respect to x, which I'll denote as y prime. And then here, k is just a constant, so is root k, so the derivative of the right-hand side is just equal to 0. Okay, so now let's isolate y prime. So we'll bring the 1 over 2 root x to the other side, so it becomes negative 1 over 2 root x. Okay, and here we'll divide both sides by 1 over 2 root y, but that's the same as multiplying by 2 root y. So multiply this by 2 root y. Okay, 2's cancel out, so what we have left here is negative root y over root x. Okay, so here's our derivative, and we have to find information about the tangent line. Okay, now we're not looking at a specific tangent line, so normally we'd take a specific point on the curve and use that to find the equation. Here we don't want to work with a specific point on that curve, so I'm going to work with some random point. So I'm going to say let x naught, y naught, okay, be a point on the curve. Okay, so we know that this point is going to satisfy this equation. Okay, and since we're trying to find the tangent to the curve at that point, I'm going to use this point and the derivative to find an equation for this line. Okay, so here let's find the tangent at x naught, y naught. Okay, so y equals mx plus b. Okay, so here y naught is our y value for our particular point. Okay, our slope. Now since I'm finding the tangent line at this particular point, in order to find the derivative, I need to input this point into the derivative. So this is negative root y naught over root x naught, okay, times my x component of my point on the curve, okay, plus b. Okay, so now let's solve for b. b is just equal to y naught, and this whole thing to the other side becomes positive, so plus root y naught over root x naught times x naught. Okay, so the equation of any tangent to this curve is given by negative square root of y naught over x naught, square root of x naught. That's the slope, okay, for the particular tangent line that I'm working with, times x plus b, which is given by this equation here. So y naught plus root y naught over root x naught times x naught. Okay, so again, complicated, looks complicated, but I'm just following exactly what I would have done to find the equation of a tangent line. The only problem is I'm having to work with a random point on that curve. Okay, so we already have the y-intercept for this tangent line. Now we need to find the x-intercept. Okay, so this is the y-intercept, and now we need to find the x-intercept. Okay, and the way in which we do that is we just set y to 0. So 0 equals negative root y naught over x naught times x plus y naught plus root y naught over x naught, root x naught times x naught. So let's bring this to the other side. So x, so it becomes positive times, okay, equals y naught plus okay, and now I'm going to divide both sides of the equation by root y naught over x naught. So x is equal to y naught over root y naught over x, root x naught. Okay, and then plus, well, when I divide this by that, it's just going to cancel out. So I'm just left with an x naught here. Okay, so I'm just going to rewrite this, okay, since I'm dividing by a fraction, it's like multiplying by the reciprocal. This is just root x naught over root y naught times y naught plus x naught. Okay, so here we have our y-intercept, and here we have our x-intercept. So now we have to add these together, and we have to hope that when we simplify, it's equal to k. Okay, so let me give myself a bit more room here, the next sheet of paper. So let's now add the intercepts. Okay. Make sure I have enough room here. Okay, so let's start with the x-intercept. So we've got square root of x naught over square root of y naught times y naught plus x naught. Okay, plus now the y-intercept. Let's recall the y-intercept is given, where is it? Up here. So plus y naught plus square root of y naught over x naught, okay, times x naught. Okay, and let's start simplifying here. So first thing I'm going to do is I'm going to simplify here, because here I've got y naught to the power 1 over y naught to the power 1 half. Okay, and those are being divided, so I'm going to use exponent law. So what am I left with? I'm left with y naught to the power 1 half in the numerator. So this is root x naught times root y naught plus x naught, okay, plus y naught. And then here, same thing. This x naught to the power 1 divided by x naught to the power 1 half leaves me with, plus just square root of x naught. Okay, so I'm just going to clean this up a little, and I'm going to rewrite it. And this is, again, one of these times where you need to be a little clever. You need to see something in the variables here. So I'm going to write x naught plus, we see that these two terms are the same. Okay, so it's 2 times, and I'll just rewrite that as x naught times square root of y naught, and then plus y naught. Okay, and like I said, this is the point where we have to be a little clever. Okay, and I want you to look at this expression, and I hope that you'll recognize in this expression, okay, a perfect square. Okay, so remember what a perfect square, if I have x plus y squared, and I expand that, I have x squared plus 2xy plus y squared. Okay, this is exactly what we have here, except what are my x and y here? Just square root of x naught, square root of y naught. So this can be factored as square root of x naught plus square root of y naught squared. Okay? Now this is when we have to go back to the original equation. If we go all the way back to the way this curve was defined, and we realize that root x plus root y is equal to root k. And remember that x naught, y naught was a point on that curve. So that means I can now replace root x naught plus root y naught by square root of k. And of course this is being squared, so equal to k. Okay, so a lot of things going on with this question. First was to find the derivative in order to be able to find the equation of a general tangent. Because I wanted to find the equation for any tangent, I didn't use a specific point, but some general point on that curve. Found the equation, determined the y-intercept, determined the x-intercept, and then used a little bit of clever algebra to solve the problem. So let me try to see if I can get the whole thing on here so it doesn't look like I can. So let me try to give you this first part, and then here is the second part. Okay, that's it. Nice question here.